Welcome back to the Cisco NetAcad CCNA3 Enterprise Networking, Security and Automation lecture series. If you haven't seen my previous lecture series covering CCNA1 and CCNA2, I will leave links in the description for those playlists. I would recommend that you go through the previous CCNA lectures before you move forward with this advanced course. Today, I will cover module number 5, which is ACLs for IPv4 configuration. The primary objective of this module is to learn how we can implement IPv4 ACLs to filter traffic and secure administrative access. We will cover how you can configure standard IPv4 ACLs, how you can modify IPv4 ACLs, how we can secure VTY ports with a standard IPv4 ACL, and how we can configure extended IPv4 ACLs. If you haven't watched my module number 4, which covers basic aspects of ACLs, I would recommend you watch my module number 4 lecture before you watch the module number 5 this lecture, because we will be building on top of what we have already covered on the module number 4. Configure standard IPv4 ACLs. Create an ACL. In our previous module, I will also introduce to some of the ways that you can create extended and standard ACLs. So in here, we will also going to discuss that a little bit here first, and then we go into in depth. All access control lists, also known as ACLs, must be planned. When configuring a complex ACL, it is suggested that you use a text editor and write out the specific of the policy to be implemented. Add the iOS configuration commands to accomplish those tasks. Include remarks to document the ACL. Copy and paste the commands into the device. Always thoroughly test an access control list to ensure that it correctly applies to desired policy. So these are the steps that you should be taking when you are thinking about how you're going to implement your ACLs. Numbered standard IPv4 ACL syntax. To create a numbered standard ACL, we can use the command access-list. So on here, you can see in this Cisco router, they are using access-list, and then you can enter the list number. So it could be a numbered value, and you can choose from deny, permit, or remark. In remark would be just a text to identify the ACL list and the source and the wildcard associated with it. So if you look at the parameters, they are listed in this table on the left-hand side with a description on what you can do with it. So if you look at this at the top against the parameters listed here, you can see the access list number, which is this one, is a number range that is either from 1 to 99 or 1300 to 1099. Deny, basically a keyword that would deny access if the condition is matched. Permit is a keyword that would permit access if the condition is matched. Remark, along with a text information, is an optional entry that would be used for documentation purposes, so it does not play a role in how the ACL is operating, but it does help you identify ACLs when you check your configuration. So it's just for human read, like human readable text that you can use to identify different ACLs. The source parameter identifies the source network or host address to filter. The source-wildcard parameter, which is the source wildcard parameter, is optional 32-bit wildcard mask that is applied to the source. Log parameter is also an optional one that would generate and send an informational message when the ACE is matched. The ACE is the access control entry, which is sometimes also known as a ACL entry, is matched. Note the use the no then access list, so that use the same access list command but the no at the front, and with the information in the global configuration command to remove a numbered standard ACL. So if you want to remove a numbered standard ACL, you basically put the no at the front and you're going to go no access dash list, and then you're going to enter the access list you want to get rid of, and then that will delete the ACL from your router. Name standard IPv4 ACL syntax. To create a name standard ACL, use the IP access-list standard command. So it is IP access-list standard. ACL names are alphanumeric, case sensitive, and must be unique. So remember that ACL names are alphanumeric. They are also case sensitive and must be unique. Capitalizing ACL names is not required, but make them stand out when reviewing the when you are reviewing the running config outpick. So if whenever you are viewing or reviewing your work after you have done everything, you want to review something, you can view or your input by running the running dash config output, and it's going to give you a lot of information. By making it capitalized, it is easy for you to identify your ACL list, but it is not required. But remember also the ACL names are case sensitive. So whatever the ACL name you used in your creation of your ACL must be the same one that you're going to be recalling to modify or change items or even disable it. So it is very important that you understand that. Apply a standard IPv4 ACL. After a standard IPv4 ACL is configured, it must be linked to an interface or feature. The IP access-group command is used to bind a numbered or name standard IPv4 ACL to an interface. So to get that standard IPv4 ACL linked to an interface or a feature, what we use is the IP space access-group command. To remove an ACL from an interface, first enter the no at the front, just like previously we have used the no command, no with the previous command. And then you're going to enter this IP space access-group with the interface configuration information. So on the bottom of this slide, you see in this router, they go IP space access-group. And then these are the options that you can configure. Numbered standard ACL example. So here is an example shown in this slide, which I will go through on a real live lab demonstration later, that shows a numbered standard ACL. So in this example, the ACL permits traffic from host 192.168.10.10 and all hosts on the 192.168.20.0/24 network out interface serial 010 on router 1. So if you look at on the right hand side, we have the access list being created up here. So the access-list 10. So this is access list number 10. And we have named it conveniently ACE. And we are using permit only host 192.168.10.10 to the internet, to the outside. And then access list 10 permit host 192.168.10.10 entry here. And then do show access list command now going to show that access list information. Access list number 10 have a permit to 192.168.10.10. The access list 10 remark ACE permits all hosts in LAN 2. So that's another one that we're going to create. It's another ACL in the access list 10. In another entry in access list 10. So the access list 10 permit 192.168.20.0 with the wildcard mask, which is 0.0.0.255. And then now if you run this, it shows those two information right here on the access list 10. We have this permit and then this one permit. And to bind this information to an interface, what we do actually, we go into the interface configuration. In this case, interface serial 010. So that's the interface that we're going to bind it to. And we're going to issue the command IP access dash group 10, and then we're going to enter out here. So that's what it's going to dictate how the ACL is administered, whether in or out. In this case, it's out. So it's IP access dash group and 10. That basically means the access list 10 will be applied to the serial interface 010. So that's how you actually create a numbered standard ACL and apply that to an interface. So you can use the command show running dash config to review your ACL configuration. You can also use the show IP interface command to verify that the ACL is applied to that proper interface. So if you run show run, and if you pipe it or select it, anything start with access dash list, it's going to display all the access lists that you have configured. And if you run show IP interface, whatever the interface you want to check, where you attach your the ACLs and you pipe it or select it, the include access list, what's going to happen is going to display the access list that's attached to that serial interface 010. So that's what's showing on the bottom of your screen here. Here is an example of a name standard ACL. In this example, ACL permits traffic from host 192.168.10.10 and all hosts on the 192.168.20.0/24 network out interface serial 010 on router 1. So in this case, what happened is we're gonna do no access list 10 because we are basically removing the access list we just created from the previous example. And we're gonna add a new access list. This one we're gonna call IP access dash list standard permit dash access. So that's the name of the access list we're gonna use. And we're gonna use the permit host 192.168.10.10 and permit host 192.168.10.10. And then we can remark the AC permit host 192.168.10.10 with the permit all host in LAN 2 with this IP address, the permit 192.168.20.0 with the wildcard mask 0.0.0.255. And we're going to bind that to the serial interface 010 by going into the interface serial 010 under interface configuration commands. We're going to enter IP access dash group permit dash access because that's the new ACL we created, and you're going to put it into as out, and we're going to exit out of that. So that would actually give you a standard ACL. So you can use the show access dash list command to review the ACL in the configuration just like before. You can also use the show IP interface command to verify the ACL that is applied to that particular interface that you're looking at. So on the right hand side, you can see that. So the show access dash list will show you all the ACLs that been in use right now, that been configured in the system. And then if you go show IP INT, whatever the interface that you have applied that or bind that in the ACL, you can see when you pipe it or filter access list on that interface, you see that the permit dash access is now applied to that serial 010. I will go through these examples in a live lab demonstration on a separate video. But for now, just know how these processes work so that you have an idea about how to configure them. There is a packet tracer file called configure numbered standard IPv4 ACLs. If you have access to this packet tracer file, please go ahead and do it right now. If you do not, I will find a copy of this file and do a live demonstration later. And there's another packet tracer file associated with configure name standard IPv4 ACLs. Again, if you have access to this packet tracer file, please go ahead and do it. If you do not, I will find a copy of this packet tracer file and post it to my sanuja.com website. as well as I'll do a live demonstration of it and post to my YouTube channel later sometime. Modify IPv4 ACLs. Two methods to modify an ACL. After an access control list is configured, it may need to be modified. ACLs with multiple access control entries can be complex to configure. Sometimes the configured ACE does not yield the expected behavior. There are two methods to use when modifying an ACL. Use a text editor or use sequence numbers. So let's look at the method of using text editor to edit an ACL. ACLs with multiple ACEs should be created in a text editor. This allows you to plan the required ACEs, create the ACL, and then paste it onto the router interface. It also simplifies the task to edit and fix an ACL. It also, another thing that has not been described on this slide is that if you were to apply this ACL on multiple routers, now you have a text file containing all that information if you do your initial work on a text editor. So you can basically copy and paste on every single router that needed to have this information once you know that the ACEs that you created is good to go. So to correct an error in an ACL, copy the ACL from the running configuration and paste it onto the text editor. Make the necessary edits or changes. Remove the previously configured ACL on the router. Copy and paste the edited ACL back onto the router. So this is a really good advice, especially if you are doing the lab exam. During the lab exam, this is what actually you should be following, because this would make you get a good grade. So in here on the bottom of the screen, we have show run being filtered out access list. So show run is used to filter out access list, and it has two accesses: access list 1 deny this one, access list 1 with the permit this one. So they have two entries. So if you want to get rid of this one access list number 1, what you're going to do is you're going to add no, then go access list 1, and it will remove these entries. And then now you can go back and copy and paste whatever the changes you made it. So in this case, access dash list 1 deny 192.168.10.10 instead of 19.168.10.10. And then the other entry is access list 1 permit and 192.168.10.0 and then 0.0.0.255. Notice that they have removed both of these entries and re-entered these entries again, even though this bottom entry didn't actually change. So it's the same thing. The reason for being, remember from our previous module and the previous lecture, we have learned that access lists do take the order into consideration. So the order of which these statements appear on the access list matters, because access lists always filter information from top to the bottom. So that's why these two entries need to be removed before editing their top entry. So you enter the top entry first again, and the second entry comes right after. Sequence number method. An ACL, ACE can be deleted or added using ACL sequence numbers. Use the IP access dash list standard. So the command is the IP space access dash list standard. So that's the command to edit an ACL. Statements cannot be overwritten using an existing sequence number. The current statement must be deleted first with no 10 command, then the correct access control list can be added using the the access control entry can be added using the sequence number. So on the right hand side you see show access dash list, and it is showing these access list. So it has a 10 denied 19.168.110.1 on the access list 1, and in here what we are doing is we are entering no 10. That means we are removing this access list entry. So this entry right here being removed with the no 10 here within the IP access list number 1, the standard number 1, and then we are re-entering a new one, which is 10 denied host 192.168.10.10. and now if you run the show access dash list, you see that this value now has changed from 19.168.10.10 to 192.168.10.10. so that's how you actually edit or delete a ACE within an access control list. Modified a name ACL example. So a name ACLs can be use sequence numbers to delete and add access control entries. In the example, the ACE is added to deny host 192.168.10.11. So on here on the bottom of the screen, if you run the show access dash list, we have the one access list, the standard IP access list with no access as the named access list, and we have two entries, two access control entries, so 1, 2, so there's two of them. And to modify them, what we have done here is we went into the IP access dash list standard no access, so we are getting into here, and we in here adding a 15, a new one, saying that deny 192.168.10.5. and if you rerun the show access dash list, you can now see the standard IP access list name no access have these three entries now. So the new entry, which is deny 192.168.10.5, is now added on top of this. ACL statistics. The show access dash list command in the example shows statistics for each statement that has been matched. The deny access control entry has been matched 20 times and the permit access control entry has been matched 64 times. So if you look at the bottom of the screen, to view the statistics, we are running the show access dash list command. So show access dash list command, and is showing how many times these entries has been matched as the traffic flow through the router. So in here it shows 20 times of this one has been matched and 64 times this entry has been matched. Note that the implied deny any statement does not display any statistics. To track how many implicit denied packets have been matched, you must manually configure the deny any command. So if you want to actually know the statistics associated with implicit denied packets, you have to manually explicitly configure deny any command. So otherwise what's going to happen is it's not going to show up on the show access dash list information. You can use the command clear access dash list counters in order to clear these statistics if you want to refresh those statistics data from your router. So if you want to troubleshoot your issues and you want to clear all of these match entry statistics, you can enter the clear access dash list counters, and that will clear all of these counters. And then if you rerun the show access dash list, you will have no entries match if there were no entries match between the clearing it and running the show access dash list command. There's another packet tracer file called configure and modify standard IPv4 ACLs. If you have access to this file, please go ahead and do it. If you do not, I will try to find a copy of this file and post to my YouTube channel as well as to my sanuja.com website, so you can download it and go ahead and do it. Secure VTY ports with a standard IPv4 ACL. The access class command. A standard ACL can secure remote administrative access to device using VTY lines by implementing the following two steps. Create an ACL to identify which administrative host should be allowed remote access, and applying the ACL to incoming traffic on the VTY lines. So if you want to implement a ACL to secure your administrative access, you can apply it by first creating an ACL to identify which administrative host to be allowed remote access, and then applying that ACL to incoming traffic on the VTY lines. And on the bottom of the screen, you do see this general command configuration you can use, which is the access dash class. And then these are the options you have available in creating that particular access list. So here is an example of a VTY access securing. So in this example, it demonstrates how to configure an ACL to filter VTY traffic. First, a local database entry for a user admin in this case, and the password class is configured. So right here in the local database, we are creating username admin, and we are creating encrypted password using the secret command called class. The VTY lines on the R1 are configured to use the local database for authentication, permit SSH traffic, and use the admin-host ACL to restrict traffic. So if you look at the rest of the configuration here, we have IP access-list standard admin-host. So that's the name of our ACL. And we're gonna name this ACL. So we have named it conveniently the description as this ACL secure incoming VTY lines. So it is easy for you to identify because of this remark when you come back to the check on your configurations. We're gonna say permit 192.168.10.10 because that would be the one that will be allowed to access the VTY lines. And deny any, and anything else is going to get denied, and you're going to exit out of it. Then what we're going to do, we're going to attach this to the line VTY. To do that, we're going to go into the line VTY configuration, so interface configuration, in this case line VTY 0 to 4 that we are configuring. And in here we're going to say logging local, transport input telnet, in this case we are using telnet, access dash class admin dash host in. So admin dash host is the IP access list standard admin dash host command that we have entered here. So that is the one here, right here we have created. So here access dash class admin dash host in is basically telling in this line VTY configuration that use this ACL in here. So it is binding that ACL to line VTY 0 to 14. And finally, you're going to exit out of that configuration, the line VTY configuration, so that your configuration is completed. Verify the VTY port is secured. After an ACL to restrict access to the VTY line is configured, it is important to verify it works as expected. To verify the ACL statistics, issue the show access-list command. The match in the permit line of the output is a result of a successful SSH connection by host with IP address 192.168.10.10. The match in the deny statement is due to the failed attempt to create a SSH connection from a device on another network. So what they don't tell you on this slide is to generate this type of data, you actually have to try accessing the SSH using a denied network and also trying to access with the allowed network. So it shows that the permit allowed network, there was two matches, so they have tried twice and it was successful, and there's twice that they have denied. So that's what is showing when they run the show access-list command. But you may not see anything match in denied if you haven't tried with something that would get denied in that configuration. So for example, if you only access the SSH using a allowed network, which is 192.168.10.10, you will have matches showing up here but no data here. That means there's nothing denied yet. But you can try from a different network and it should denied and should show up as matched here. Therefore, you can verify that the line VTY port security applied is using ACL works. Configure extended IPv4 ACLs. Extended ACLs. Extended ACLs provide a greater degree of control. They can filter on source address, destination address, protocols such as IP, TCP, UDP, ICMP, FTP, etc., and port number. Remember, I briefly described the differences between extended ACLs and standard ACLs on my module number 5 previous lecture. So this is the same statement. So the differences is that the extended ACL compared to standard ACL have a greater degree of control because it can filter on source address, destination IP address, protocol, and port number. That means basically it can operate even in layer 4. Extended ACLs can be created as numbered extended ACLs, which are created using the access-list command with the access list number and in the global configuration command, and the name extended ACL option that is created using IP access-list extended command with the access list name as an option in there. So these are two ways to create extended ACLs. Protocols and ports. Extended ACLs can filter on internet protocols and ports. Use the question mark command within the Cisco iOS to get help when entering a complex ACE, access control entry. The 4 highlighted protocols on the right hand side here are the most popular options used today, but all of them are valid options because that's why it's showing up here. So if you go access-list 100 permit, and then before completing this command, you can put a question mark and hit enter, and that will give you the options that you can pick, and you still have the initial command that you enter here. You just have to pick one of these and then press enter. So in here you can go access-list 100 permit ICMP or IP TCP. You can do HP, EIGRP, etc., etc. So the most commonly used ones are the ICMP, IP, TCP, and UDP. But however, for your lab exams, your instructor may ask you to use something else, such as EIGRP and OSPF and etc., etc. But most common ones are ICMP, IP, TCP, UDP. So those are the protocol options typically being used in ACLs. Again, you don't need to memorize this for your lab exams because you can use this question mark command to view all the options available to you, but have a general knowledge of these options so that you are better at understanding the concepts behind ACLs. Selecting a protocol influences the port options that will be available once you have selected the protocol. So many TCP port options are available as shown on here on the right hand side. So remember, on the previous one we have entered access-list 100 permit and we are not sure what options we have, so we add the question mark and hit enter, and it gives you all the protocols options we have. But now we have selected the TCP as our protocol and we have given the parameters for it, any, and then now after that we have equal to what. So in this case we are not sure, so we're gonna enter the question mark command and press enter, and you'll see a whole list of options that can be picked for that TCP protocol. So the most common ones would be the domain, FTP, FTP-data, POP3, SMTP, Telnet, and www. So these are some of the options that are available on the Cisco iOS that can be picked as one of the options for that TCP. However, any of these things such as CMD, daytime, IRC, any of these hostname, all of these are valid options as well. These are just the commonly used, mostly used options. But yeah, again, the other options are also available for you to use. What you need to understand for exams and quizzes, especially for your lab exam, is how to use this question mark command. And remember to use this question mark command, because during the exam you don't have a lot of time, you have a limited time. So if you don't remember something, you should be able to quickly pull this thing out and figure out what you need to enter and go from there. The better yet, if you have a lab manual that you're allowed to take into your lab exams, make sure you understand how these access list commands work, and make sure you know the format of entering these access list commands, so that you don't waste your time during the exam trying to figure out how to create an access list. Protocols and port numbers configuration examples. Extended ACLs can filter on different port number and port name options. This example configures an extended ACL 100 to filter HTTP traffic. The first access control entry, or ACE, use the www port name. The second access control entry in here uses the port number 80. Both ACEs achieved exactly the same result, because that's how the iOS is built. So the Cisco iOS is built in a way you can either use the www, which is the name, or you can use 80, which is the port. So either or would work. Configuring the port number is required when there is not a specific protocol name listed, such as SSH, which is the port number 22, or HTTPS, which is the port number 443, as shown in the next example. So when there is a situation where there is no specific protocol name is listed, so if you go in here, there is no specific protocol name for HTTPS port 443. We only have the www for port 80. So in that case, to secure web traffic for HTTPS instead of just HTTP, you have to use the port number in this case, because there is no specific protocol name built into it in the current Cisco iOS software, right? So because of that, we're going to do access dash list 100 permit TCP any equal to port 22 for the SSH, and access dash list 100 permit TCP any equal to 443 for the HTTPS, the port 443 web data. So that's how you do it, because there is no listed protocol name in here associated with SSH or HTTPS. So that's why we must use the port number in this situation. Apply a numbered extended IPv4 ACL. In this example, the ACL permits both HTTP and HTTPS traffic from 192.168.10.0 network to go to any destination. The extended ACLs can be applied in various locations. However, they are commonly applied closer to the source. I have mentioned this couple of times in my previous lecture in module 5 as well. Extended ACLs can be applied anywhere you like. However, typically we apply as close to the source as possible. Here, the ACL 110 on this example is applied inbound on the R1 at interface G000. So right here, access list 110 permit TCP this, and we have entered this one, access list 100 permit TCP 443 and www here, and then the interface G000 get binded with this ACL information. This ACL information get binded to this interface, and which is by entering the IP access dash group 100 in. So that means this ACL information get now binded to that interface G000. Then you exit out, so the configuration is done. TCP establish extended ACL. TCP can also perform basic stateful firewall services using TCP establish keyword. So the keyword is established with the ED at the end. The established keyword enables inside traffic to exit the inside private network and permits the returning reply traffic to enter the inside private network. So the primary purpose of established keyword, remember, to enable the inside traffic to exit the inside private network and also to permit the returning reply traffic to enter the inside private network. The TCP traffic generated by an outside host and attempting to communicate with an inside host is denied. So any other TCP traffic generated by an outside host, however, and attempting to communicate from inside to an inside host will be denied. So that's the key feature of establish keyword. So in here on the bottom of the screen, we see this diagram trying to explain that. So you have an inside private network and you have a outside public network. So if the TCP request from PC1 to the outside public network is permitted, then the TCP reply traffic returning from the outside source will be permitted, because the initiating party is the inside private network party, right? It's a device within the private network that initiate that TCP request. Therefore, the reply back from the outside with the TCP reply would be allowed. However, if the outside public network device try to initiate a TCP request, it will be declined from the outside public network because of the way that the established keyword works. In this example, the ACL 120 is configured to only permit returning web traffic to the inside host. The ACL is then applied to outbound on the R1 G000 interface. The show access -list command shows that inside hosts are accessing the secure web resources from the internet. Please note, a match occurs if the returning TCP segment has the acknowledgement or ACK or the reset or RST flag bit set, indicating that the packet belongs to an existing connection. So a match only occurs if the returning TCP segment has the ACK or RST flags bit set, indicating or differentiating that that packet is belong to an existing connection. So in here we have the access list -120 permit TCP any with this IP information and the wildcard with the established command. See, established. So it is now then applied to interface G000. So it's right here, this ACL is now applied to that G000. And if you run show access -list, you can see the extended IP list showing up here. Right here, permit TCP with the any equal to 443. We have a 657 matches. And then the extended IP list 120 right here with the established showing 1166. Right here, that's the established command being used. Name extended IPv4 ACL syntax. Naming an ACL makes it easier to understand its function. To create a name extended ACL, use the IP access -list extended configuration command. So what you're going to do in configuration command is you're going to enter IP space access -list extended. That's the command we're going to use. So in this example, a name extended ACL called no-ftp-access is created and prompt change to name extended ACL configuration mode. So whenever you created that that new ACL, it's going to change it to the ACL configuration mode right here. So in this example, that's what it's showing. ACE statement or access control entry statements are entered in the named extended ACL sub configuration mode. So this is a sub configuration mode now. Now you can enter whatever the ACE statement associated in here. So here is an example of a name extended IPv4 ACL. The topology show that it has a inside network and an outside network. So we are now trying to apply two name extended IPv4 ACLs to an interface. So we have a name ACL called surfing. This will permit inside HTTP and HTTPS traffic to exit to the internet. So the surfing ACL, the name ACL, will permit the inside HTTP and HTTPS traffic to exit to the internet. Browsing is another ACL we have here, and this will only permit returning web traffic to the inside host while all other traffic exiting the R1G00 interface is implicitly denied. So the browsing, this will only permit returning web traffic to the inside host while all the other traffic exiting the R1G00 interface is implicitly denied. So we have two name ACLs that we are trying to apply here. So we have a surfing one and the browsing one. So right here. So remember that network diagram that we saw on the previous slide. So now we are looking at the configuration on the right hand side on that router. So the surfing ACL permits HTTP and HTTPS traffic from inside users to exit the G001 interface connected to the internet. Web traffic returning from the internet is permitted back into the inside private network by the browsing access control list. The surfing access control list is applied inbound and the browsing ACL is applied outbound on the R1G000 interface. So you can see that on the right hand side. So we have applied the IP access group surfing in. So it's an inbound. The surfing is in the G00 inbound. And IP access group browsing out, it's in the outbound. We are applying the other browsing ACL list. And you can see the ACL list are being created right here. So the surfing one created right here. And the browsing one is created right here. Note that the browsing one is using that establish command because it's only allowing to return packets back to the internal network if the TCP connection is initially initiated by the internal device itself. So now then we're going to apply the surfing one, which is this one, as the in and the browsing one as the out. And if when you run the show access dash list, you can see those showing with the statistics. I will go through ACL examples in a separate lab demonstration video, but for now just remember the basic concepts associated with this and how you can configure it as we go through the hands-on lab that I will be posting later on my YouTube channel. You'll get to know more about these options later. The show access list command is used to verify the ACL statistics. Notice that the permit secure HTTPS counter, which is 443 in the surfing ACL, and then return established counter in the browsing ACL have been increased. So you can see that in here as well. Again, I will actually show you all of these in a lab demonstration. Again, stay tuned, subscribe to my channel and thumbs up my video so that more people see this, and also you can view my next upcoming useful informational based videos as the time goes by. So I will post a very good lab demonstration on these ACLs later sometime. So how do you edit extended ACLs? An extended ACL can be edited using a text editor when many changes are required, or if the edit applies to one or two access control entries or ACL entries, then sequence numbers can be used. So in this example, the ACE sequence number 10 in the surfing ACL has an incorrect source IP network address. So right here on the surfing, this IP address, they're saying, well, it's incorrect in this example, right? So to correct the error, the original statement is removed with the no, remember no command in the Cisco IOS, with the sequence number, and then the correct statement is added later. So show IP access dash list command output verifies this change has been applied. So in here at the top image on your bottom of your screen, we have entered into the IP access list extended list of surfing. So we are inside the configuration there, and we're going to enter no 10. Right? Why did we do that? Because remember 10, this is the one, right? We're going to try to get rid of. And then we're going to say re-entry 10 permit TCP with the new information. Now, if you go show access dash list, that new information is now listed in here because we have removed that 10 and modified it in this surfing access list. Another extended IPv4 ACL example is shown here. So in here we have the same network diagram. We have an inside a private network and an outside public network. Now we have two other ACLs. This one called the permit-PC1, the other one called reply-PC1. The permit-PC1, this will only permit PC1 TCP access to the internet and deny all other hosts in the private network. So only PC1 can communicate to the outside. Reply PC-PC1, this will only permit specific returning TCP traffic to PC1, implicitly denying all other traffic. So that means it will only allow the specific TCP reply back to the PC1, not just random ones coming from outside the network. So in this example, the permit-PC1 ACL, permit PC1, which is 192.168.10.10 IP address, TCP access to the FTP, SSH, Telnet, DNS, HTTP, and HTTPS traffic. The reply-PC1 ACL will permit return traffic to PC1. The permit-PC1 ACL is applied inbound, and the reply-PC1 ACL is applied to outbound on the R1G00 interface. Remember that? So this is outbound. This is inbound. This is inbound. That's outbound. Yeah. So if you go back here, so the outbound is G000. So that would be this one. This is outbound. Sorry. So this is the inside network. It's going out. So this is outbound interface. So this is coming in. This is the inbound interface, the incoming traffic from the outside. So G00 is the outbound. G001 is the inbound. So in this case, what happened here is that the reply-PC1 is applied to the outbound G00 interface. So on the right hand side, it shows the configuration for that router. We have the IP access dash list extended permit PC1. That's the extended ACL that we are creating here, and we have some identifier information enter here with the remark, and we have permit the TCP host and denied and certain the other ones, and then we have applied those to the interface G000 being applied as IP group permit per PC1 in as the inbound, and IP access group reply PC1 out as the outbound. So the outbound is applied here and the inbound is applied here. Sorry, I think I confuse people here. So forget about inbound, outbound here. Inbound, outbound associated with whether traffic is coming in this port or going out. So inbound is like coming in or going out. But it's also a little bit confusing because this is the inside facing interface, this is the outside facing interface. Not so in here when they talk about inbound and outbound, they are not talking about inside and outside facing interface, they're talking about incoming traffic and outgoing traffic. Sorry about that. So this is showing that IP access dash group permit PC1 is inbound and reply dash PC1 as outbound. They are both, however, applied to the interface on the inside network, so the G00 interface. So that's what it's showing. Again, I'll go through the lab demonstration that will make it so much easier for you to understand rather than just going through Cisco standard lecture notes, right? So yeah. Verify extended ACLs. So the show IP interface command is used to verify the ACL on the interface and the direction in which it was applied. So you can actually see that in here. So again, when you say inbound and outbound, it is a direction of the traffic flow, not the interface. Sorry, my apologies. Okay, so remember that. So when we say it's the same interface, but we are applying one inbound, the other one outbound. So when you run show IP interface G000, because that is the interface that we have applied those ACLs, you can see the outgoing access list is the reply IPC1. Why? Because see, reply PC1 is out. And the inbound access list is the permit PC1. So inbound in right here, permit PC1. And they are both applied to interface G00. So that's showing in here with the show IP interface G000 command. The show access dash list command can be used to confirm the ACLs work as expected. The command displays statistics counters that increases whenever a access control entry is matched. Please note the traffic must be generated to verify the operation of the ACL, as I mentioned before. So this is the same command that I have introduced before, and we're just going to run that to see the verification of these ACLs are working. To do that, remember, you need to generate some traffic, otherwise it won't actually show you the data. The show running dash config command can be used to validate and verify what was configured. The command also displays the configured remarks, and you can see show running dash config with filtering the IP access here with the pipe function. So you can see that being displayed right here as well. There's a packet tracer file called configure extended IPv4 ACL scenario 1. And there's another packet tracer file called configure extended IPv4 ACL scenario 2. If you have access to those packet tracer files, please go ahead, download it and do them. If you do not have them or you don't have access to them, I will get a copy of those two packet tracer files and post to my sanuja.com website, and I will leave a link in the description of this video once I get hold of those. So for now, if you have access to them, do it. Go ahead, do it. In next few days, I will post it to my sanuja.com website, so you can go ahead and do them. And that would bring us to the end of this module. And I will introduce you to a few new packet tracer files that you can do, as well as the summary of what we have covered. There's a packet tracer file called IPv4 ACL implementation challenge. If you have access to this, please go ahead and do it. If you do not, I will try to find a copy of it and post to my website. There's another file called lab configure and verify extended IPv4 ACLs. Again, if you don't have access to this file, I'll try to find a copy and post to my sanuja.com website. So here is a summary of what we have learned. So the next few slides, that's what I'm going to cover. We learned to create a numbered standard ACL. We need to use the IP access-list standard command with the options available in the global configuration. We use the no access-list with the options available in the global configuration command to remove a numbered standard ACL. We also learned show IP interface command to verify an interface that has an ACL applied to it. We learn how we can create a name standard ACL using the IP access-list standard with the options available in the global configuration command. We also learn how to use the no IP access-list standard with the options associated with that to remove any name standard IPv4 ACLs. We learn about how we can bind a numbered or named a standard IPv4 ACL to an interface. Remember, to do that we use the IP access-group with the whatever the list, ACL list associated with that in the global configuration command. We also learn about how to remove ACL from an interface with again using the no as a keyword in front of the IP access-group this time in the interface. We learn about how you can also remove the ACL from the router with the use of the no access-list in the global configuration command that will remove the entire ACL list. We learn about extended ACLs that can be used to filter source address, destination address, and protocols such as IP, TCP, UDP, ICMP, HTTP, etc., and the port number. So that's the primary advantage of using an extended ACL as opposed to a standard ACL. We learn how we can create a numbered extended ACL by using the access-list command and the options associated with that. We also learn about ACLs can also perform basic stateful firewall services using the TCP established keyword. Remember that established keyword. So I don't know why anybody want to not to use a firewall, but if you're in a small office environment, for example, you can actually just use ACL to apply some basic firewall functions using that established keyword. The show IP interface command is used to verify the ACL on the interface and the direction in which it was applied. We also learn how we can modify an ACL, use a text editor, or use sequence numbers. So to modify an ACL, we recommend that you are using a text editor or use sequence numbers. An ACL access control entry, also known as ACL ACE, can also be deleted or added using ACL sequence numbers. Sequence numbers are automatically assigned when an ACE is entered. So remember that as well. So whenever you enter an access control entry, it will automatically, the sequence number will be added like a 10, 20, 30, 40, etc., right? So you'll see the sequence numbers appearing when you enter an access control entry. And that is the end of this lecture. If you like these type of videos, please thumbs up this video and subscribe to my channel. If you have any questions with respect to ACLs or anything that we have covered previously, please do not hesitate to contact me either through leaving a comment in my YouTube videos or through my sanuja.com website. Please go over your notes before you take your exams. And until next time, good luck and have a nice day.